Hello, welcome to AERI. My name is Rob Hammond, I'm the president. Our mission is to keep your production lines moving. Let me show you how we do that. In this video, we describe step 2 of our 3-step process, external characteristics. Now we begin to examine the individual parts. First, we remove the sample quantity from random locations in the packaging. Then we pull the manufacturer's data sheet and confirm the components are the correct part. We compare it to the customer's purchase order to make sure we have exactly what they ordered, the right manufacturer and quantity. Now it's time to put the parts under the microscope. After years of experience, our QC techs can spot a fake easily. All of our techs can accurately judge whether or not a part has been blacked up just by looking at the surface under the microscope. A real part has a dull look with sharp peaks from the plastic molding process. If the parts are sanded down, then blacktop, they usually have a more glossy finish and the peaks look more rounded as the paint settles within the original peaks and valleys. If the parts are sandblasted, in order to remove the old markings, there will be telltale signs of the underlying material of the part. Plastic encapsulated parts have silicone embedded in the plastic, which shows up as small glass spheres when the plastic surface has been etched away. Then we verify that the logo and markings match the manufacturer's specs, as well as comparing them to other similar products we've received over the years. We're also looking for inconsistencies in marking placement and quality. Often when an inexperienced counterfeiter uses a second-grade laser marking machine, they'll burn holes in the part. You can see in this image that the part has both laser burn marks and the logo's missing important elements of the Philips brand. When the counterfeiters try to create a large lot, they have to group together different parts, oftentimes with different variations in the body of the components. The pin 1 placement and other indents need to be consistently placed on all of the parts. In this example, some of the parts were missing pin 1 indicators within the exact same lot. Sometimes the process of refurbishing the part leaves telltale signs of counterfeiting. We've seen flux, chemical residue, dirt, tool marks, and paint where it doesn't belong. These parts were obviously mishandled, leaving micro debris on the surface. Another used sign is cracks or chips on the body of the part caused by the stress of removing it from a circuit board. Looking at the leads under the microscope can tell us a lot as well. Used leads are difficult to get back into perfect condition. It's easy to spot used and refurbished leads because they're often bent, scratched, and if they're retinned, you won't be able to see the copper core at the tip of the leads. Old parts should not have perfectly shiny leads, and new parts shouldn't look tarnished. For BGA packages, we look to see that they're not reballed. Some of the signs of BGAs are scratches that go under the spheres, odd-shaped spheres, or contamination from the soldering process. We are also looking at the condition of the leads to see if they have signs that may make them difficult to mount to the customer's board. Are the leads oxidized, corroded? Do they have socket marks from previous use? Solvents testing. If the parts pass all the visual tests, we confirm that the surface is not remarked or blacktop through a series of solvents tests. We first take a solution of 3 parts mineral spirits and 1 part isopropyl alcohol to check for marking permanency. This is the test that the manufacturers are required to set their standard to. If the markings are wiped off with this solution, you likely have a fake. Then we try acetone, which is a much stronger solution. If the markings come off with this, that's okay, but there should not be any black paint coming off onto the cotton swab. We also scrape the parts at a very sharp angle with a razor blade. If we see paint flaking off, we know the parts are blacktop. For some of our specialty military and aerospace testing, we can perform the Dynasolv 750 and 1-methyl-2-pyrrolidinone heated chemical test. But the other tests have almost certainly detected whether or not the parts are fake at this point. Once all of the conditions of the parts pass, we confirm the size of the part and the pin count based on the manufacturer's specifications. The attention to detail throughout our process, along with the comprehensive review of the parts, are what differentiate AERI. We go through this painstaking process to keep your production lines moving while assuring your customers that your products can be trusted. To learn more about our additional steps in our inspection process, or to speak with someone about your electronic component needs, call one of our search experts or visit our website at aeri.com.